A very, very good evening to you all, and welcome to today's session. I'd like to begin by thanking you all for your patience and your understanding. We're supposed to meet last week, but due to the challenge I had on the road, couldn't meet. Thank you for your patience and understanding. I'd like to also welcome you to the new year. Welcome to this new year, and I believe that we're still going to maintain the same commitment that we had in the last year as we continue our journey into the CCNA training class. Today we'll be looking at Module 13. And this Module 13 is a follow-up of the last class that we had last year. Additionally, it's supposed to be the class we're supposed to had last week, and so we're just having as a follow-up. All right. Module 13 will be a very brief chapter, and it's talking about ICMP, Internet Control Messaging Protocol. We will be explaining how ICMP works and how it is used to test network connectivity, and we'll be using ping and traceroute as ICMP protocols to test end-to-end utility or connectivity. ICMP version 4 and ICMP version 6 messages. Internet Control Messaging Protocol provides feedback about issues relating to the processing of IP packets under certain conditions. ICMP version 4 is the messaging protocol for IP version 4, and ICMP version 6 is the messaging protocol for IPv6, and it includes additional functionality. The ICMP messages common to both ICMP version 4 and ICMP version 6 includes host reachability, destination or service unreachable, and then time exceeded. So the concept of ICMP generally is to test end-to-end connectivity of devices. Okay? Is to test end-to-end connectivity of devices. And so once this test is ongoing, it tells us whether it can reach the device, whether it is unreachable, or maybe the time has exceeded. And what happens is it sends what we call an ICMP echo message. All right. And it can be used to test the reachability of a host on a network. For example, the local host sends an echo request. This is the request is H2 reachable. This is H2 here. Okay, so it sends a request, which is a question to verify the reachability of H2. And then H2 will say, yes, I am. All right. And once it says, yes, I am, it will send a reply. Okay. So if it is available, it will send a reply. Okay. Now, how about when they say destination or service unreachable? What happens? An ICMP destination unreachable message can be used to notify a source, the source at the destination or service is unreachable. And the ICMP message will include a code indicating why the packet could not be delivered. So a few destination unreachable codes for ICMP version 4 includes, once the code is 0, it means that the network is unreachable. Once the code is 1, it means that the host is unreachable. Once the code is 2, it means the protocol is unreachable. Once the code is 3, it means the port is unreachable. Okay? These are the codes for ICMP version 4. There are 4 of the codes. For ICMP version 6, code 0 means no route to destination. And when they say no route to destination, it's like saying network is unreachable. Okay? So they are like similar. And then code 1 says communication with the destination administratively prohibited, probably by firewall. And it is similar to this, which means you cannot reach the device. And this time around, it is being specified that it was blocked. Okay. Then code 2 for ICMP version 6, it says that it is beyond the scope of the source address. That is the protocol unreachable. Beyond the scope of the address, which means that there are certain addresses that are prohibited from reaching out certain places. And so this is the kind of problems that you have. Then code 3 says that the address is unreachable. Then code 4 means that the port is unreachable. Okay. Now, how about the time exceeded? Remember when we were looking at IP version, the IP header, we looked at something called the TTL. The TTL simply means time to leave. It says when the time to leave in a field packet is decremented to 0, the IP version 4 time exceeded message will be sent to the source host. Okay, so once you send a ping, there is a value of the time to leave. Okay, for instance, let me show you. Let me share my screen. All right. Let me share my screen. Okay. So I'm sharing my screen now. So if I run a ping and I say maybe google.com, for instance, you see that I'm sending a ping to Google and look at my time to leave as 53. Can you see it? This is it. This is the time that the packet is given to leave. And as it transcends from one router to other, it decrements down. Okay, because I'm using the command ping. All right, I'm using the command ping. Ping is an ICMP protocol. Okay, or if I use traceat and I say google.com, you will see that it's also an ICMP command or tool. And then in this case, it's going to now tell me the hops that the packet is going through as it is checking the trace. Okay, it's going to tell me the hops. Don't know why it's taking long. Okay. So as it tells me the hop, it means that it's going to be decrementing by 1 as it jumps the hops. But the concept is that TTL has a value, which is this guy here, and it decrements. I don't know why this is not going through. Maybe we'll try it again later. Okay, now it's going through. Oh, it's going through now. Yes, it's going through now. So you see that is telling me from my system is going to, this is my system here. This is the IP address. This is the IP address of my router, the one IP address of the gateway. This is it from my ISP. This is how it's going. So it's going to be counting my hops as it is traveling to Google. You could see here that it has a maximum of 30 hops. So once the hops are more than 30, in this case, it's going to tell me that the time is exceeded. Okay, the time is exceeded. Once the hop is more than 30, that's what it's going to do. But it's going to be listing the hops as it goes down. Okay, see, as it goes down, it will be listing them, and then as it goes continuously. So let me stop it. Now, if I also ping my gateway, sorry, if I ping, let's see, 192.168.0.1. Now, you will observe that there are two things here. you see this time here, you see it's 4 millisecond, 1 millisecond, but see the average of 3 milliseconds. But look at the time here. You see it's about 151 milliseconds, 116, an average of 133 seconds, milliseconds. It means this is the time it took this system, this is an average time it took this system to go to Google and come back. But you see, when I'm pinging my router here, this is the time in milliseconds that takes it to just check to my router and come back. So you see, this time is smaller. So what we are saying is that the time that you see here is the time it takes the packet to go to the destination and then come back. But once the TTL value turns to 0, then you will get the answer like the expired in transit. Now, ICMP version 6 has new features and improved functionalities do not found in IP version 4, including protocols as part of the neighbor discovery, ND, all right? So messages between IP version 6 routers and IP version 6 device, including dynamic address allocation as follows, like router solicitation message, router advertisement message. Now, messaging between IP version 6 include duplicate address detection and address resolution as follows: the neighbor solicitation message and then the neighbor advertisement message. All right. So those are the additional features that ICMP has that you don't find that in IP version 4. Now, the router advertisement message are sent by the IP version 6 enable router every 200 seconds to provide addressing invitation information to IP version 6 enable host. What is this RA or router advertisement? It's trying to say that this router, for instance, here, is trying to say, okay, hey, I am available as a gateway to whoever that is belonging to this particular local network. So you see, the router advertisement is now sent to a local network. And then this particular PC will now take the advertisement to say, I have an advertisement of a default gateway that I should add in my IP address configuration. So it's going to pick the IP address and add as a default gateway. So anytime this PC wants to go outside of its local network, it will now use the IP address that has been advertised to it. So the RA message can include address information for the host, such as the prefix, length, the DNS address, and the domain names and things like that. So a host using stateless address auto configuration will set its default gateway to the linked local address of the router that sent the router advertisement. Okay, now an IP version 6 enable router will also send out an router advertisement message in response to a router solicitation. Now, what is this router solicitation? So the solicitation now is sent by the PC. For instance, the PC is soliciting for requests. Okay, so you see in the picture, PC1 sends a solicitation message to determine how to receive its IP version 6 address automatically. So it's like, hey, I am on the network now. I'm looking for an IP configuration. Does anyone has to provide for me? Then the router can now reply with the router advertisement. All right, that is how it works. Now, a device assign a global IP version 6 unicast or linked local address may also perform duplicate address detection, which is DAD. All right, and that's when you have a conflict, IP conflict. Okay, so to check the uniqueness of the address, the device will send a neighbor solicitation message with its own IP version 6 address as targeted IP version 6 address. If another device on the network has its own address, it will respond with a neighbor advertisement message. So a neighbor advertisement and solicitation is to say, okay, hey, I have gotten this IP address from this router, I hope nobody else have this particular IP address. And then if nobody has the IP address, bam, then you maintain it. But if somebody has the IP address, then you will get a notification as regards that. So to also determine the MAC address for the destination, the device will also send a neighbor certification message to the solicited node address. So the message will include like the targeted IP version 6 addresses. The device that has the targeted IP version 6 address will now respond with the neighbor advertisement message containing the MAC address. So you see this concept of neighbor certification or neighbor advertisement messages, or whichever one that is done, is just a way of sending information. And what kind of information? IP-based information on interfaces. All right. So I'm new on ground, so I'm looking for IP on how I'm going to move out. And then I now solicit for message. Okay. Or I am looking for I want to advertise my route to others. Then I can now do my route advertisement. But once I get the information, I now cross-check with my neighbors just to ensure that me and my neighbors were not in conflict. We don't have the same IP address. Okay. Now, the concept of ping and traceroute test, like I've done earlier on, is just to tell you that you can run a ping in order to test end-to-end reachability. So the ping command is like an IP version 4 and IP version 6 testing utility that uses ICMP echo request and echo reply message to test connectivity between hosts and provide a summary that includes the success rate and average roundup time of the destination. So you see, if the test is done on a router, it tells you the success rate and the failure rate, and then it will tell you the number of packets that have been sent, how many have received, and it will tell you the success rate of the round trip. Okay, so you can do it by just typing ping and then a space, then the IP address if it is IP version 4. For IP version 6, you do ping space and then the IP address, which is IP version 6. So you get the same reply. So if a reply is not received within the timeout, the ping provides a message indicating that the response was not resolved. All right. And so that timeout is like the TTL value that is being given. Okay, so it's common for the first ping to timeout or to fail if addresses or ARP or neighbor discretion discovery needs to be enabled first or so. So sometimes you run the ping, you see the first one fails, and the reason is just you are running a ping for the first time. The ARP need to be working. Okay. And after the first ping you have done, others will be successful. Anyone that follows after that will also be successful. How about when you are pinging your loopback? Remember we talked about the loopback interface. The loopback interface is just the IP address of your network interface card as by the manufacturer. Okay. So you can use it to test the configuration of your IP version 4. Okay. Can use it to test that. Okay. So, like I said, a response from this, which is the loopback interface for IP version 4, or this is the loopback interface for IP version 6. If you run a ping, it indicates that the IP is properly installed. So for instance, if I just come here and I ping 127.0.0.1, this is the loopback interface. I should be able to get response. Okay, I should be able to get response. I see 0 milliseconds. It simply means that my network interface card is working very, very well. But if you are unable to get it, if you're using IP version 6, you should be able to do double column 1. You should be able to get that. If you want to ping your default gateway, you have to know the default gateway. The default gateway in this case, if I do IP config, is the IP address that takes you out of your local network. So you see, in my own case, this is my default gateway. All right, this is my default gateway. So that's in my own case. So, and it's usually the IP address of your router. So the ping command can be used to test ability of a host to communicate with the local network. So the default gateway address is the most often used because of the router is normally always operational. So a successful ping to the default gateway indicates that the host and the router interfaces serving the default gateway are both operational on the local network. So if the default gateway addresses does not respond, it means a ping sent of the IP address to the other host may not be operational. So if this is a PC, this is the default gateway because of the interface of this particular router. That's the router it follows to go outside. But if you're unable to get a reply to this, it simply means that your PC cannot go out to the internet. How about when you want to ping a remote host? Okay, a remote host maybe is another system that is remote to your own. So you can use ping to test the ability of that and to check the connectivity on your local network. So a local host can ping a host on a remote network and you can get a successful ping. Once you get a successful ping, it simply tells you that your network is fine. Okay, for instance, this is this PC here, all right? And you want to test reachability of this PC here. This is a particular network. This is another different network. They are all separated by this router. All right. So this is a different network. This is a different network. So if I'm able to run a ping and it comes here, it simply tells me that everything pertaining my traffic on this route, there is no problem. Okay, that is just what it means. So for instance, when I ran a ping to test reachability to google.com, it simply means that I have internet. If I can get a reply to Google, it means that I have internet on my system. Traceroute or TraceSat is a utility that is used to test the path between two hosts and provides a list of hops that were successfully reached along the path. Okay, so the traceroute we usually use when you're using a router, or TraceSat usually used when you're using a PC to test the end-to-end. Okay, so traceroute provide a round trip time for each hop along the path and indicates if a hop fails to respond. An asterisk is used to indicate a lost or unreplied packet. So this information can be used to locate a problematic router in the path or may indicate that the router is configured not to reply. Right? So like what I did earlier on, I run a TraceSat. All right, I can say trace@google.com. So it will just begin to list the different hops that my packet has to pass through in order to get to Google. All right, so it will start from your host router and then it will go to your ISP. Then from your ISP, it will go through the different routers within your ISP. Once it's done with that, then it goes to the tier 1 ISP, to the tier 2 ISP, to the 3, all the ISPs until it gets to Google. All right. And once it gets to that particular point, it tells you that your network is fine across all this particular path. So you see, it is still rolling. And it is still rolling because it's moving from one different network to the other. One different network to the other. Okay. So you see, it has a request timeout at a particular point because the TTL value for that particular listing expired. So it's going to continue. Okay. So remember, the TTL means time to leave. All right. So it's checking. So you see, at any point in time, I can even verify Who owns this network? Who owns this network? Who owns this network? All these IP addresses are different networks globally that this thing is traveling to. All right. Remember that it goes through a maximum of 30. So it should go to less than 30. Whatever happens, this number of routers that it must cross in order to get to its destination should be less than this. So it's still showing us the path that our router flows through. So I can check, this is an IP address, okay? And I can check who owns the IP address. Can check who owns this IP address, right? And things like that. So those are like IP addresses of, you know, the ISP within themselves and things like that. So it's still rolling, and it will keep rolling until it gets to Google, right? So let's continue. Once we'll come back and see what happens here. So the first message sent on traceroute will have a TTL field of 1. This causes the TTL to time out on the first router. So for instance, now, you are sending a particular ping, maybe from here to this guy here. So you see, the traffic comes here, it comes to this, comes to this, comes to this, comes here, and comes here. So you see it's saying TTL is 4. Why is it 4? Because of the number of hops that it has to cross in order to get. So you see the trace route then progressively increments the TTL field 2, 3, 4 for each sequence of message. This provides the trace with the address of each hop as the packet timed out further down the path. So the TTL field continues to be increased until the destination is reached or is incremented to a predefined maximum. Okay. All right, so this is it for today's class, but I'm going to do a packet tracer activity with us, and then we will call it a day, okay? All right, so in this activity, is a packet tracer activity, we're going to use a ping to test network connectivity. So part 1 says tests and restore IP connectivity, which means some will have problems or thereabout. Then 2, test and restore IP version 6 connectivity. All right. Now, in this scenario, it says that there are connectivity issues in this activity. In addition to gathering and documenting information about the network, you will locate the problems and implement acceptable solutions to restore connectivity. It says, note that the user executive password is Cisco. The privilege password is class. So let's do instructions. Part 1, test and restore IP version 4 connectivity. Use the IP config and ping to verify connectivity. Remember, the ICMP protocols are used for troubleshooting. Okay, so you're using ping to test end-to-end connectivity. Once there's a problem or there's troubleshooting issue, you're trying to fix it. So it says click PC1 and open the command prompt. Where is PC1? Let me put this at the top. Okay. Where is PC1? This is PC1, I guess. All right. So it says click PC1 and open the command prompt. So this is the command prompt. It says enter the IP config all command to collect the IP for information. So I will do IP config /all. Press enter. So this is what I have. Okay, this is what I have. Now it says complete the addressing table in the IP version 4 subnet. What is the IP addressing table? Come in here. Where's PC1? This is PC1 here. we're supposed to put the IP address, and the prefix. We're supposed to put default gateway, okay? So for PC1, so this is PC1. So we're supposed to put IP address, subnet mask, and default gateway. So what I'll just do, I'll just be putting it on a notepad on the Microsoft Word so that we can work with it. So let's put this one like this. What is the IP address? This is the IP address. And that's my, okay. Put this one down here like this. So I say PC1 IP address. Uh-oh, I think I didn't copy it properly. This is the IP address here. Okay. Subnet mask 255.255.255.0. Uh-oh, yes. No. Look at it. It's not .0. It's 255.255.255.224. Default gateway. This is it. Okay, so all right. Now let's come back to our activity and see what, right? So they say we should collect the information with IP address, subnet mask, and default gateway. Done. Click PC3 and open the command prompt. If we do, we're supposed to do so. Let's come to PC3. It's PC3. Expected to open command prompt. Then we do ipconfig /all. So you see, this is the IP address 10.10.1.18. This is the subnet mask 255.255.255.240. This is the default gateway. Okay. So, all right. So enter ipconfig all command to collect all information and complete the IP address table. So we're supposed to now complete for PC1, 2, 3, and 4. All right. So assuming we've done that, it says locate the source connectivity failure. So we want to connect where there's problem. From PC1, enter the information necessary to trace the route to PC3. Good. So from PC1, we're supposed to trace how to get to PC3. So this is PC3. This is the IP address of PC3. So I will just come to PC1 here. And then I will do, they say we should trace at PC3. Is that not so? So it's going to now check and tell us where there is a failure. All right, so what we're going to do, maybe let me put it on simulation mode. Let me end it, put it on simulation mode. And then, okay, so that we can see. All right, so PC1 goes to switch, then goes to the router, and then router. So the traffic is not leaving the router. Can you see? It's not leaving the router. So there's a problem here. We're supposed to come to PC3. So you see, there's a problem here. So let us open PC1 and see. Can you see? We're having a problem. All right. Okay. All right. So what I'm going to do now, we're going to run a ping. Okay. We're going to run a ping and then see the behavior. Ping this. Okay. So, all right. Traffic has come to the switch. From the switch is in the router. And then it moves from router 2 to router 3. And then okay, okay, okay. Can you see how it's moving? Now, there is a problem somewhere. So we're going to find out where the problem is. Okay. So you see, it keeps telling us destination reachable. So we're going to find out. Okay. Based on the addressing table that we've seen, where's this thing? Just a minute. Based on the addressing table, router 1, you see, router 1 has 2 interfaces. Okay. It has G00. This is G01. And then this one here should be, okay. This one too is also GI01. See? Okay. Uh-oh. It is going now. I want us to see. Okay. It has 2 interfaces, gigabit Ethernet 0/0 and gigabit Ethernet 0/1. You see 0/0 is connected to, is up, but there's no IP address. Can you see that? It's up, but there's no IP address. Then gigabit Ethernet 0/1 is up. There's an IP address 10.10.1.97. Okay. So there's an IP address in that one. All right. So there's an IP address in this one. This one, there's no IP address unless maybe it's IPv6. Let's see. There's no IPv4, but IPv6. I think there's IPv6. Yes, there's IPv6. See the IPv6 over there for gigabit Ethernet 00. So it has IPv6. Okay. So now if this guy is on 10.10.1.96/27, what is the IP address that is giving it here? So let's do IP config. You see, this is the IP address 10.10.1.98. Okay. So our question is it on the right subnet mask? Remember, we talked about subnetting. Okay. We talked about subnetting. Now there are online tools that will help you quickly do your subnetting. Let me show you. You can just say IP subnets or subnet calculator. So subnet calculator. I would advise that before you begin to use all these subnet calculators, make sure that you are already familiar and you know how to use it. Okay. So If I'm saying /27, I want to find out the subnet mask, for instance. Okay, so /27, can you see? So my subnet mask is going to be 255.255.255 dot what? 224. Can you see? So if I use that 255.255.255.224, it means that the you see 224, it means this is very correct. Then the next thing, my default gateway, does my default gateway have 1.97? That is what it should have. So I'll check here. Okay, Cisco enable class, that's the password. So if I say show IP interface brief, okay, I want to see the IP address. Can you see? Gigabit 0/1. I'm having 1.97. 1.97, right? So which means this information from here to here is fine. Okay. The next thing is to check between router 1 and router 2. Router 2 is connecting to router 1 on this IP network, 10.10.1.4. Let us check it here. You see the serial interface is saying 10. Where is it here? See 10.10.1.6/30. This is the subnet mask here. Then for serial 0/1, that's here. And then for the router 2, which interface will this be now? Okay, serial 000. And 000 is 10.1.1.5. Okay, 10.1.1.5 and then 10.1.1.6. Right? So let's check what is in here. So if I check here, sorry, I think we're working on this. Let's check the serial interface. This is the serial interface 10.10.1.6, which is correct. Can you see it here? Then I will check the other one, this guy here. Check here. This thing is Cisco. Password is class. Show IP interface brief. So I have 10.10.1.9, which is for serial 01, which is correct. And then for serial 00, 10.10.1.5. There is a problem here. You see, it's supposed to be 10.10.1.5, but it's giving us 10.1.1.2. Okay, so that is the interface here. This is where our problem begins. Okay, and then, so you see, if you run ping, you'll be able to see the problems and then you compare with your documentation. So this is one of the problems here. Now let's check router 3. Let's check router 3. If I do Cisco class to show IP interface brief, serial interface 001, we have 10.10.1.10, which is router 3. You see, 10.10.1.10. This is correct. The Ethernet interface is 10.10.1.17, which is correct. Okay. So if this is correct, the one that is problematic, this is the 10. This should be 9, because this is 8, so this should be 9. This is 10. You see, this is supposed to be 9, which is this one here. Then this is supposed to be the 5. Okay, so let's see. This is on router 2. This interface is serial 00. What now? Router 2, we have 000 and 001. See, this is what interface now? Okay. So 001 instead of 9, this is correct. Then 000 supposed to be 5. So let's correct this. So how do we correct it? We go to config terminal, interface serial 0/0/0. Then you see IP address 10.10.1.5. Subnet mask 255.255.255.0. It's done. And then it's saying is overlap. Okay, subnet mask is not 255.255.255.0, dot 252. Right? Yeah, 252. Good. So I'll say no shutdown. Then do right to save my configuration. Moment I've done that, you see my completion says I'm 50%. Okay. So we have done one problem. I've solved one problem. Then the other problem, since this is the first problem, the other problem should be IP version 6 related. So let's continue in this activity. So we have done that. It says locate the source of the problem between PC1 and PC3. So we have located it and fixed it. Was there a successful ping reached? So I think there should be successful ping reached. This is 1.18. So from PC1 now, let us ping it and hope that we should get reply. Good, beautiful. So you see, we have a reply. So which means problem solved. Okay, problem solved. All right. Having solved the problem, we now go to, it says trace, okay. From PC3, enter the necessary command to trace to PC1. Okay, we have done all that. Okay. Okay. Good. It says repeat steps 2E through 2G with router 3 and record your answers. Click router 2, enter and log into the router. We've done all this. Enter the show IP brief command and record the addresses we have done. Run the test if it virtualizes. Okay. So we have done that. So the next thing is for part 2, test and restore IP version 6. Use the IPv6 config and ping to verify connectivity. Click PC2, open command prompt, and then enter the IPv6/all command. So this is PC2. Go to command, So now use IPv6, IPv config /all. Okay. So we're going to get the IP addresses, the IPv6 address, and so on and so forth. So we're going to compare it with what we have on the table. All right. So click PC4 and open the command as well. So where's PC4? Open the command as well. Sorry, IPv6 config. Right, so this is also the IP address we have. Right, so you say test connectivity between PC2 and PC4. It should fail. So I should copy this IP address and I come to PC2. And then I should ping. If I ping this, it's saying that this should fail, right? So you see it's giving us a request timeout. It should fail. So now the activity is saying we should locate the source of the failure. So from PC2, enter the necessary command to trace where the problem is. Okay. So I can now say trace that. Then I'll put the IP address here. Okay, so you see we have done, it has crossed the first, okay, second and third. So we'll need to find out. So where did it stop? It stopped at 3.2. Okay, so this is this does come first, second, third. So 3.2. So this is where we are expecting our problem to be in this particular distance. So let's check router 3 table and check the IP version 6 configuration. Okay, so let me see, show IPv6 interface brief. All right, so on the serial interface, this is what we have. The serial interface 2001 DB8 132, which is okay. And then our link local FEAT :3, which is okay. All right, so we are good on that. How about the gigabit interface on router 3? Gigabit interface 2001 DB8 14:1 14. So everything seems to be fine here. Okay. All this is /64. Think so. Where did we go wrong? Okay. Anyway, let's check here. So exits. So show IPv6 interface brief. All right, so let's check serial 001. Serial 001, we have 200 DB8 131/64. Good. And then this one here, 2001 DB8 121/64. And also we are good. right? And then okay. So I think so. Where did we go? What is the problem? Or let me use simulation mode and then run the ping again, and let's see where it failed. Okay, okay. Comes to the switch, goes to the router, goes to router 2, goes to router 3. So it stops at router 3. Okay, it's coming in here. Okay. All right. So, which means if we check here, see it's saying request timeout. And it's the same request timeout here. So this is our problem. DB8132. This is the last check that we got correctly. So if we are to verify it, 132, it's going to be on router 3. 12132. This is the last one. Serial 00/1. Okay. So probably this may be, and we will find out. So 00/1. So the traffic came to this point. So probably it's not leaving here. So gigabit 0/0. Let's find out what is there. Gigabit 0/0 2001 db8. Okay, db8 colon 1 colon 4 double colon 01, which is okay. Okay, so we are trying to find out. So let's come to the client. The client, let's see what IP address does it have. IP version DB8142. Right, so that is it. So if we check our result here, let's check where we are missing which item. Sorry, it's not showing us. I wanted to see if you are having difficulty visit the resource. It's not showing us. I'm trying to get the point. Our traffic came in to this point. This router. And then let's check here. Okay, you know what? Let us do step by step. From PC2, let us ping, let's ping to this router interface, to this router interface. Okay, let's ping to here. So ping Right, so you see we're getting reply to this router interface. Good. Now, let us check for this particular interface. Let's check to this particular interface. Check into this particular interface. Let's check. I run a ping, and then I paste it. And then you see I'm getting a reply. All right. We're getting a reply. So which means we are getting traffic even to router 3. Okay. The problem now is the IP address for router 4. So where is the PC4? The PC4, sorry. We come in here, IP configuration, and then let's copy this. Then let us check. Okay, where are we running the test from? I think, oh, we're running the test from the wrong. Oh, we're right. Okay, so if I do ping PC4 here now, oh, you see, I'm not getting to PC4. So let's, and the IP address is okay. Is it okay? So traffic is just not coming out. Okay. 6 gigabits. Okay, this is 2001 DB814 double column 1. Then PC4 should be, where is it? Where is it? Here it is. 14 double column 2. That is PC4. Okay, so from this PC, can we run a ping? Running a ping, this. Okay. Okay, so you see we are fine here. However, we are not fine going out. So this is what we're going to do. If I'm going to pick the IP address from PC4, okay, this is the IPv6 address. So let's ping it from inside the router. Okay, let's ping it from inside the router and see. Okay, from inside the router, we're getting success. Can you see? From inside the router, we are getting success. But, okay, let me check from inside this router. Do we get success? Paste it. Okay, so you see there's a problem. From inside router 2, there is no success. So router 2 cannot cross over. Okay, so what do? We check the routing table. Okay, so first of all, if I do show IP route, or show IPv6 route. Now with the show IPv6 route, I can see because the network I'm looking for is this one, 2001 DB8, column 1, column 4, double column. Okay, that's the network I'm looking for. So I should have it directly connected or so locally. Got it, 2001 DB8, column 1, column 4. Look at it here. This is what I'm looking for. So it is there and exists in this particular router. And this D here is telling us is EIGRP. So let's check in this router too. We'll say show IPv6 route. Let's see whether we're going to see it 2001. Okay, that has learned. Look at it here. 2001 DB8, column 1, column 4, double column /64. So EIGRP has learned it. So we have the routes here, we have the routes here. So let me see. Is there anything that we're missing? All right, so maybe I'll find out what it is we're missing, and then I will let you know, right? Okay, so if you are joining us, I can see a number of you have joined the class. I'm sure you'll be wondering why I have not communicated I've not communicated the class about this session before time. Okay. I noticed that where I am now, anytime from 8:20, I may not have good internet connection. And that is why I just quickly decided I'm going to record this session, which was for the previous class, and then drop it for you on the class platform. And then when we come to meet for tomorrow's session, then I'm going to take in questions and answers. So I was supposed to be done before most of you enter, but I can see quite a number of you are already in the class. So since you have already joined the class, a number of you, the topic we are looking at today, just a minute. So the topic that we are looking at today is ICMP, okay? And we're able to look at the configuration of the routers and the networks, and we're able to see how we can implement ICMP, especially in the aspect of ping and in the aspect of traceroute. So I'll be dropping the recording. Please pardon me after the recording, jot out your questions, your answers when we meet tomorrow by 8, because I'm afraid where I am, network will soon go off. I've been informed that we'll have a big network challenge here, okay, by 8:15 or 8:20. So you pen down your questions. We're going to meet later. Once again, thank you very much for being part of today's session. Have a very good night.